Hello guys, so in this video I'm going to talk about how to find a unit binomial vector. So what makes a unit binomial vector different than a unit vector, unit tangent vector, and unit normal vector is that it actually combines all three of these, and the unit binomial vector is the unit tangent vector crossed with the unit normal vector. So for step one, what we're going to do is we're going to find the unit tangent vector, and the unit tangent vector is given by this formula, r prime divided by its magnitude. So we're going to find the unit tangent vector. So the first thing we need to do is we need to find r prime. So given that our position vector r of t is 12 cosine t, 12 sine of t, comma 5t, the first thing we need to do is differentiate this. In doing so, when we take the derivative, we get 12 sine of t, negative 12 sine of t, 12 cosine of t, and then 5, because we're differentiating with respect to t. And now the next step is we need to find the magnitude of this, so the magnitude of r prime. So in doing so, we take the terms, we square them, add them, square root them. So negative 12 sine t squared plus 12 cosine t squared plus 5 squared. And in doing this, what we're going to do is we're going to distribute the square. So we know negative 12 squared is 144, sine squared is sine squared. 12 squared is 144, cosine squared is cosine squared, and then 5 squared, of course, is 25. So now what we're going to do is we need to make this radical a lot easier to work with. So basically what we're going to do right here is, notice how we have a 144 for the first two terms, so we're going to factor it out. So 144 is going to be factored out, and we're left with sine squared plus cosine squared plus 25. And notice how the 25 is separate from this. The 25 is not going to the factoring because in essence we only factor two terms. And if we know the Pythagorean identity of sine squared plus cosine squared, we know it's equal to 1. So we can actually just go ahead and just substitute it. So 144 times 1, because that's equivalent to sine squared plus cosine squared plus 25. And we know that when we add 144 plus 25, we get the square root of 169, which is actually a perfect square of 13. So that's our r prime magnitude. So now we have the unit tangent. We're trying to find the unit tangent vector. So now what we do is we divide the r prime divided by its magnitude. So to compute our unit tangent vector, we divide negative 12 sine of t, the first derivative of the position vector, divided by 13, and then the middle term, 12 cosine t, divided by 13, and then the last term, which is 5 over 13. And that's our unit tangent vector. So now we can move on to step 2. So now that we have the unit tangent vector, the next step for step 2 is we're going to find the unit normal vector. So in doing this, if you don't know how to compute it, I have a video on that, but basically what we do is the formula of the unit normal vector is taking the unit tangent vector derivative divided by its magnitude. Thus we get a unit normal vector. So recall that our unit tangent vector that we just computed was 12 over 13 sine of t, comma positive 12 over 13 cosine of t, comma 5 over 13. So that's our unit tangent vector. So the first thing we need to do is take the derivative of this function, of this vector, and in doing so, the derivative of negative sine of t is negative cosine t, so negative 12 over 13 times cosine. The derivative of cosine is negative sine, so negative 12 over 13 times sine of t. And the derivative of a constant, which is 5 over 13, that would just be 0. So after that, now we have to compute the magnitude of this. So negative 12 over 13 cosine t squared plus negative 12 over 13 sine of t squared plus 0 squared. So now we're going to keep simplifying this. So we know we're going to distribute the square. 12 squared is 144, 13 squared is 169, cosine squared is cosine squared. Furthermore, we distribute it. And we know 0 squared is 0 squared. And from here on, what we're going to do is we're going to eliminate the 0, and we can factor out 144 over 169 because it's a common factor for the sine squared and the cosine squared. So we can factor that out of those two terms. So we're left with cosine squared plus sine squared, and the 0 just goes away. And we know that we can apply the Pythagorean identity that sine squared plus cosine squared is equal to 1. So we can go ahead and substitute that sine squared plus cosine squared for 1. So in essence, we're left with 144 divided by 169 times 1. And when we take the square root of each term, the square root of 144 is 12, square root of 169 is 13. So we're left with this as our unit tangent vector of magnitude. So now we have the two elements we need to compute the unit normal vector. So again, the formula for unit normal vector is the unit tangent vector derivative divided by its magnitude. So we know the unit normal vector that we have when we plug in what we have is negative 12 over 13 cosine of t divided by the 12 over 13 comma negative 12 over 13 sine of t divided by 12 over 13 comma 0 divided by 12 over 13. So now what we're going to do is we're just going to go ahead and simplify this. So let's try to cancel out as much as we can. So we know the 12 over 13 will cancel out in the first two terms, and then in the last term we know the last term goes to 0. So furthermore, when we simplify this, what are we left with as our unit normal vector? We're left with negative cosine of t comma negative sine of t comma 0, and that's our unit normal vector. So now we can move on to step 3. So now that we're at step 3, what we're going to do is we need to find the unit binormal vector. So recall that the formula for the unit binormal vector was the unit binormal vector is equal to the unit tangent vector crossed with our unit normal vector. And recall that our unit tangent vector that we computed was negative 12 over 13 sine of t, positive 12 over 13 cosine t, and then 5 over 13. And our unit normal vector that we computed was negative cosine t, negative sine of t, and 0. So what we're going to do is we're going to compute the cross product. So we're going to apply the cross product, and if you don't know how to do it, I have a video on that. But basically what we're doing is we're going to cross these ijk. The first thing we're crossing, since it's the unit tangent goes in the second line because the unit tangent needs to go first. If you put the unit normal vector terms first in the second row and you put the unit tangent terms in the third row, what you're going to end up getting is you're going to get the negative answer. So we don't want that. So remember, tangent comes first. So unit tangent cross with unit normal. So when we do this, we take our I and we're going to cross it. So 0 times positive 12 over 13 cosine is 0 minus negative 5 over 13 sine. And this is our I. Our J is 0 divided by negative 5 over 13 cosine of t. And again, if you don't know how I'm doing this, I'm not going to go too much into detail of how to compute the cross product because in essence, you should know this by now, but if you don't and you're not comfortable with it, I do have a video that I highly recommend you watch on how to compute a cross product. And the k component of our vector would be positive, because negative sine times negative is positive sine squared, 13, minus negative 12 over 13 cosine squared. And this is our k component of our vector. So our unit binormal vector comes out to be 0 minus negative 5 over 13 sine t would be positive 5 over 13 sine of t. And then we know that middle term is going to be negative 5 over 13 cosine t because we do have a negative for our j components. And our k term is going to be positive 12 over 13. And where's that coming from? Because when you factor out, because in essence this is sine squared plus cosine squared, so you can factor it out and get 1. And that's our unit binormal vector. Thank you for watching. I hope this was helpful.